right? Is everybody awake?
Is anybody awake?
Anyone awake? Is everybody ready for happy hour? Hacker hour. That's
Hacker hour.
I like that.
Excellent.
You should coin that. You should trademark that.
Right.
Okay, so we're here to talk about the security header injection module. We acronymed it SHIM.
I voted for the security header injection tool, but I got outvoted, so it's a module.
Up for debate. Anyway, so we're going to talk about this guy. Let's do some introductions first. My name is Eric Johnson. I'm a security consultant, focus a lot on static code analysis, developing security-related tools, doing penetration testing. I also do a lot of work with the SANS Institute and the Application Security Curriculum. I author and teach the Dev 544 Secure Coding in .NET class, and do a lot of different marketing and other efforts within the AppSec curriculum for SANS.
And I'm Aaron Cure. I'm also a security consultant with Cypress Data Defense. That's who we are. And I also do a lot of security tools development, so a lot of internal stuff. And then I also teach secure coding class. So.
Okay, so agenda today, we're going to talk about the OWASP Secure Headers project and
the secure header injection module tool. Thanks, Eric. I figured you took the last one. You're going to let me have this one? So basically, the OWASP Secure Headers project, the whole point of it is to raise awareness of the client-side protections. Has anybody here ever used the CSP, Content Security Policy? Hey, that's 3 more than I've ever seen in any other talk. You should pat yourselves on the back. Fantastic. X-frame options, anybody ever used it? HSTS header? Not a whole lot. You know why? Because most people don't know it exists. You guys, you come teach. We'll go early beer hour. So basically, the whole goal is to let people know that they actually exist, to show what they do for them, make it easy to add and configure. Our module, 3 pieces in the web config, it's ready to go. And then there are 2 other implementations right now. SourceClear has one called Headlines. It's a Java implementation, and Twitter put one out for Ruby. So there's 2 other ones in the project if you want to go check those out.
so we're going to show a quick demo here. Everyone loves live demos, right?
Little.
Guy. So we have a little a site we use for demoing and training and things like that. This guy has vulnerable and safe examples. So what we're going to do is start with our vulnerable examples. So the way that this is configured, the module is installed in this site, but it is excluding all of these vulnerable pages. So we're going to walk through the vulnerable pages, see what the problems are, then we're going to go through all of our headers, and then walk through the safe pages and see how it changes things. So who's familiar with the caching headers? That's an old one. It's been around for a while. So we've got a page here. We based all of this demonstration software off of the movie Office Space, so if you don't like the movie, I apologize. This is Milton's information up here, right? This has got all sorts of goodies in it. It's got account numbers, SSNs, routing numbers, W4 information, all the fun things an attacker might try to get a hold of, right? So if we look at this, we went ahead and clicked on the page. Let me get over to my network tab here. So this is just the web console in Firefox for those of you that haven't seen it. If we hit refresh on this, we'll see a bunch of GET calls, and we'll see the call into our caching page, right? So let me go ahead and click off of this. Go ahead and hit the CDD exploit page, which is our home page. And if you go back here, oh, that wasn't supposed to maximize. We said you never know what you're going to get, right? We went back to the default page. We've got our GET. So when we come back here, if I hit the back button, we'll come right back into our page, and we'll notice this is now empty. What does that tell us?
That's right, page is cached.
There's no request made to pull this page back up. This is our caching vulnerability. What happens if we're on a machine in a library or some sort of public shared server, right? This information is being stored locally on the server, and through other vulnerabilities, attackers love to find these things and pull these pages right out of memory on the box, right? So that's the caching problem. Questions on that? Pretty straightforward, right? Let's take a look at the second one. Remote script inclusion. Has anyone heard of BEEF? The browser exploitation framework. Got a bunch of people raising their hands. That's good. Has anyone used it on somebody? All right, a couple people. I like to send my wife emails with beef hooks in the email. and see if she'll click on them. And then you can start launching all sorts of alert boxes and ask her how her day's going, and it freaks her out. But anyway, so we click on our link, and let's pretend we've got our remote script included in this page. We get our evil alert dialog pop up. So we'll go ahead and dismiss this. Let's take another look back in our console here. We've got our get right here. And actually, if we look in the page source, I just want to show you where the actual hook is. So it was evil.js. So you can see right here, we've got our embedded script tag right here. Do you see that in the back? Should we zoom in on it a little?
Yeah, but you have terrible vision. We can't say that.
All right.
Get closer, James. That's all there is to it.
There we go. So there's our embedded script tag. That's what's performing all of the malicious activity. It could be running port scans against your network. It could be stealing your cookies, your hidden fields, all of these fun things that attackers like to do if we can inject script into your page. So another vulnerability that simple use of our headers that we'll go through can help prevent. Our third example is our clickjacking example. If we go ahead and launch this page, it brings us to a malicious site so we've got our blue banner up here. That's our malicious site, right? And if we come down here, we've got the red site. You can see it kind of moving around in the frame. That is an iframe that's hosting our site. So if you're performing clickjacking attacks, have anyone heard of the like jacking, those types of things? So we can do whatever we want with this frame. We can hide it, and we try to get our victims to click on a button at that point. So those are our vulnerable demos.
We could show their site, float another frame over top of it, and then when they click, they're actually clicking on our frame instead of the one below that they're seeing and things like that.
Yep, absolutely. All right, so back to the slide deck. On. No. Okay, so that brings us to our implementation. It's an HTTP module. Has anyone implemented HTTP modules in .NET before? They're good, right? They run every request. It's kind of like a filter in Java. Every request that comes through the IAS pipeline, the module hits it. Right now, we're claiming it supports 4.5 because, to be honest, that's what the project defaulted to, and that's what we built it under.
We haven't tested it anywhere else, but it should run.
Should run. It's not using any crazy libraries. It's all stuff that's been around forever. It supports web forms and MVC, and all we have to do is modify 3 things in our web.config file to turn this on. So here's what we need to do. Our config sections element in the config. We go ahead and add the section, reference the CypressDefense.shim configuration class. We've got our default configuration. All you have to do is add that one line, shim enabled true, and that will add every single header that we're going to talk about to your response headers. And then the module registration, we need to tell the module to actually run. So we go ahead and put that in there, and then that's what triggers that code to execute on every request that comes through. So here's the list of headers that we support. We're going to walk through each of these one by one just to set the stage here a little bit. This is a lot of information. There's 40-something slides in here. We're not going to go into a ton of detail on each of these. If you have specific questions about them, let us know. We'll stick around. We'll get a beer afterwards, whatever we want to do, and we can talk about it. But some of these are pretty lengthy. So
if you want to talk about content security policy, we'll go get 3 beers because it is a talk.
All you, buddy.
All right. So the first thing we're going to talk about the caching headers. One of them, Pragma, has been around forever. That's an HTTP 1.0 tag. We also have the expires header and the cache-control header. So what they do, the cache control options header is supported by HTTP 1.1, so it's not backwards compatible. So you need to set this one, and it basically has 2 options, well, 3 options: no cache, no store, or must revalidate. So the must revalidate is just going to force it to go get the page again before it comes back. Then we have the expires tag. It has basically 2 options: value, which everybody, if you've ever seen the expires tag, it's expires value equals -1. Or we have enabled. The enabled just lets you turn it on and off, and it does the same thing. That it sets the value to -1, so that's the default. And then we have the Pragma tag. Like I said, the Pragma tag is the HTTP 1.0 backwards compatible, so you have to set both the cache control and the Pragma to make sure you can cover the whole spectrum. And it just has a no cache option, so it's Pragma no cache. So this is what the default configuration gets you. So if you say shim enabled equals true in your web config, this is what you're going to get. You're going to get cache control enabled with no cache, no store, and must revalidate, and the expires tag on with a value of -1, and pragma enabled to no cache.
Questions about the caching configuration? Pretty straightforward. Okay, we're going to jump into the X-frame options header. This is what we use to prevent our clickjacking vulnerability that we showed in the demo. When we can frame that page inside the iframe, that means that the attackers can use that and trick people into clicking buttons on it. What we need to do, we can go ahead and set the X-frame options header. Our default value is deny. That's what we want to default to. It means you can't do it. The browser won't allow it. There are other options. We have same origin, which means that you can frame the page. It's got to be under the same host, port, and protocol, same origin rules. So if you've got, does anyone have a site that uses iframes all over the place? We've got one in the back. I'm sorry, I feel bad for you that you have to deal with
I
that.
noticed you looked at the floor when you put your hand up, though, so we all feel your pain.
I've reviewed several sites that do that. You can use X-frame options, but same origin is what you're going to have to set up unless you need to cross over into other domains. If you need to do that, the third option is allow from. You can actually specify a URI there and say this origin is allowed to frame my site. A little bit of an issue with that. That allow from option doesn't have full browser support. IE and Firefox are the main takers there. If you've got users under Chrome, Safari, Opera, you might run into some issues. But keep your eye on it. Maybe they'll start supporting that sooner than later. And this configuration is very easy. We've only got the value. It's deny, same origin. Or allow from, the URI goes in the empty one, but this is our default state. We're going to deny. This is going to run secure by default, and you don't have to add any of this stuff, but you can override it.
All right, anybody see any problems with this? Can anybody see this? If you notice, you've got the safe icon, right? So you're good. This is an HTTPS site, right? Until you look at the HTTP link. So this is the great, anybody ever heard of a neat little tool called SSL strip? Yeah, no, it hasn't gotten a lot of press. Nobody's really heard of it. But what it allows you to do is a man-in-the-middle attack on SSL. So basically, they connect to you, HTTP, and then you connect HTTPS out, break it out, and bring it back. With this new neat little feature, you can actually use the fave icon and put a little lock right up there. So the browser thinks you think you're safe, everything's good. So basically, what we're going to do is we're going to set the strict transport security header. And it's obviously, by its simple acronym, HSTS, right? So it's actually the HTTP strict transport header. And so you'll always see it evaluated as listed as the HSTS header. But basically what it says is this site must always be SSL. And if you set this header, it allows your browser to cache that value, and from then on, every time it goes to this website for the whole domain, it will require SSL. Basically, we have some options. We have max age. We have include subdomains. When I said it's in the entire domain, it's the entire domain, but it doesn't necessarily include subs. So if you have www dot and static dot, if you don't include subdomains, then static dot won't be covered unless you specifically say it. Pretty good browser support. Sometime after IE 12, it's supposed to maybe be supported in IE, but nobody uses IE. It's definitely not used in the corporate world, so we're good. Oh yeah, I forgot, default configuration, secure by default. So basically, strict transport security is enabled, the max age is a year, and it includes the subdomains. So basically, it's going to cover your entire domain paths and everybody underneath it.
Questions on HSTS? Anybody? All right. Quiet crowd. X content type options. Who's used this guy? This is our solution to try to fix IE's problem of trying to guess the content type of our page. If you specify a content type of application/text, but then have a bunch of JavaScript in the body, IE decides, well, you know, it looks like this is JavaScript. Let's execute it. It's a great idea, right? So X content type options, we basically set it to no sniff, and that tells the browser, hey, if I tell you it's a text content type, render it as text. Do not try to guess what it is. So that's what we're trying to protect against. Like I said, no sniff is the only option. IE is really the only reason this is around. Browser support, for some unknown reason, Chrome didn't have the problem, but they still implemented support for it. No one knows when or how it got there, but it's there.
We're going to fix a problem we don't have.
Yeah, just in case our developers make a mistake later, we'll be covered. IE 8's when it started, so we're good on that. Our default configuration is no sniff. It's the only option, right? It's enabled by default again. There's enabled, you're seeing a theme with these enabled properties, right? You can turn all these off if you want to, but they're all going to be there out of the box.
Okay, this is one of my favorites. Anybody ever buy this product? It is fantastic. I used it last night, had some friends over. Delicious. They were perfectly cooked. Little XSS vulnerability here that Sears had in their website where you could just reflect whatever you wanted into their shopping cart for your tagline, so kind of fun. Yeah. So basically, we're going to stop that. We're going to turn XSS protection on through the x-XSS protection header. Basically, you have three options. 0 for disabling the XSS filter. 1 allows the XSS payload to be dropped but renders the rest of the page, and mode equals block blocks the whole page. So if there's an XSS detected, it won't let it through at all. Browser support, IE, and Chrome at some time because it just works. And then again, the default configuration, the value is 1, so it's going to block the XSS content but let the rest of the page render, and block equals true.
Okay, content security policy. Yes?
Just one question. I don't even know why you want to do this, but can you set this at the first page level, like say I want X-frame off on one page?
Absolutely. We'll get there. Great
question. Hold that to the end.
We did think of that. There's a couple slides here in a little bit, and we'll show you how to do that, because it is needed, mainly for caching. Yeah, I love when you lead me into what we're going to talk about. It shows that you're paying attention, which is good. Okay, we're going to talk about content security policy first. This is our longest and most drawn-out topic in the deck because there's so many options. There is a webcast that I did for the SANS Institute that's a half an hour, 35 minutes on CSP alone. It's on a link I'll show here in a little bit. So, like I said, we're not going to spend a ton of detail in each CSP option, but that webcast is out on the SANS AppSec archive. If you want to sign up for it and watch that, you can get some more information and some tools to build CSPs.
And the whole slide deck is already out on our blog, so you can, each one of these is fully covered on the slides. We're just going to kind of blow through it because it does a lot of stuff.
Yep. So, more importantly, a fun example. Has anyone heard of strong webmail? Nobody. This is good. So, the first thing I'll tell you is if you're a startup company and you have this hot new product, do not offer a $10,000 reward for someone to hack into your site. It's just not a good idea. Okay, strong webmail. They were kind of the pioneers of two-factor authentication. Get a code on your phone, you got to type it in to access the site. Does everybody use that? Hopefully for PayPal, hopefully the iCloud now. Has everyone set that up already? So they were kind of the pioneers of it. They said, you know what, let's offer a $10,000 reward to the first person that can break into our site because there's two-factor authentication. No one can break into that, right? So cross-site scripting, let's talk about it. Some guys picked that up, they registered for the site, they found a cross-site scripting vulnerability, and they created an email and laced it with cross-site scripting code to steal all of the session cookies and send them back to their server so they could take the identity of that user and log right in. Does that make sense? So what do you think they did? They emailed the CEO of the company and said, had their payloads in there, they called customer service and said, hey, we just won your contest. We sent your CEO an email with the steps that we used to break into the site. So the CEO angrily goes right to the website, logs in, opens up the email with all the cross-site scripting code in there. The attackers get the cookie, and then they're holding one of those huge checks for $10,000 2 days later. So that's what we're trying to protect with CSP. We do not want remote code executing in our site. There's lots of other things out there or here that we can cover, but that's the main one. So it's the standard header is content-security.policy. You'll see lots of other variations, x- and there's another one that, this is what the spec says now. So content-security.policy. Default source is self. And we'll get into these here in a minute, but basically what we're saying is this is a list of people that we trust, and we are only going to load content from those people. So there's some keywords we need to familiarize ourselves with. Self is the most important one. That's the same origin, right? That's only resources from our same host port and protocol. None means we're not allowing this whatsoever. We've also got unsafe inline, unsafe eval. Those are the types we can actually run JavaScript, things like that. Because by default, there's no inline JavaScript, no inline CSS styles. Everything has to be externalized in a trusted file, which can be hard to use, but that's the safe. Data is also another one. Does anyone use data URIs? So you don't need to worry about this, but if you use data URIs, it's actually, there's a lot of attacks where you can craft an XSS payload and then base64 encode it and put it in a data URI, and the browser will conveniently decode that and launch the attack for you. It's a nice way to bypass request validation for those of you that think that actually works. Okay, all the different areas. Default source, we can specify scripts, we can specify objects, styles, medias, frames. Those are all the options. Again, these are talked about in a little more detail in the SANS webcast on content security policy, so we'll get a link out to that here in a minute. So let's look at an example, because that's where it gets fun. So this is one from mobile.twitter.com. Basically, this is in report-only mode. Does anyone use report-only mode for this? This is kind of like putting a WAF in learning mode. You can monitor it and see what it's doing, but it doesn't actually break anything yet.
Anybody ever put a WAF in learning mode? Anybody ever take one back out? Yeah, that's generally a problem. Went to a customer site. They said, oh, well, this isn't an issue for us. Well, why not? Well, we have a WAF. Okay, can you show me the configuration? Well, sure, here you go. Well, your WAF's in learning mode. Well, yeah, we want to make sure that everything that's coming through is good. Yeah, but it's not protecting you. But we have a WAF. But it's not protecting you because it's in learning mode. Yeah, but that's because it's learning. But it's not protecting you. So after 3 days, they finally put it into enable mode, and they were amazed at how much traffic stopped coming through.
So if you look at the bottom, you'll see the report URI. That's the URI that they're going to send these little JSON packets that has the violation that occurred. So you can log all the violations there, and it helps you build out your content security policy. So if you see here, Twitter's allowing images from Twitter, the TWIMG domain, google.com. Scripts are only allowed to come from reCAPTCHA, Twitter. They've enabled unsafe inline and unsafe eval, which weakens your content security policy. But we'll talk about that here in a minute, especially for web forms and .NET. Browser support, this is supported pretty much across the board except for our old friend Internet Explorer. They're a little slow to the game here. Hopefully in the next version, version 12, this will be implemented and supported, per the spec anyway. And this is a web forms configuration of CSP. So does anyone notice in web forms and .NET how it emits a lot of JavaScript and inline CSS styles that you have no idea why it's there or where it's coming from? So in order for CSP to work with web forms, this is the configuration you have to set up. So this is not the default. Like I said, we're secure by default. You will need to modify this. This is documented on the Codeplex page that the tool is on. There's an example sitting right there, and I actually just pasted it into this slide. So it tells you what you need to do to use CSP with web forms right there on the Codeplex page.
Instead of secure by default, we call this the more secure because we have to.
Yeah.
So
hopefully, well, who knows, the framework maybe at some point will start externalizing all of that out of the web pages, and then we can have a very secure CSP on the site. But as of right now, this is really our only option. Unless anyone from the .NET development team is in the room. Anyone? No? All right.
Maybe next week.
Yep.
And then back to your question, is there a way to specifically say, leave this page out, configure it by page? We have a set of exclusion lists for each one of the objects. So caching, content security policy, X-type, X-frame, XXSS. There's too many X's and S's in that particular header, in my opinion. So basically what you do, thanks, Eric.
Sorry.
In your configuration, you can set caching enabled and set cache control enabled, and then you can exclude any particular page, any particular image, any particular directory. Basically anything that you can hit with a location path, you can hit with the exclude list. So you can just add in pages, especially for caching. There are a lot of static type stuff that you don't want to bang back every time, hit the database, regenerate that page when caching is okay. So you can exclude that kind of stuff. I don't know why you would ever want to exclude an XSS protection unless you have a demo site that you want to show that it's okay to XSS, and then we do that. And this is how we handle our vulnerable sites inside of our demos over here is we just exclude the pages that are in the vulnerable directory.
Oh,
That's you.
the demo. Okay, so we're back. We're going to go through the same couple of examples. We'll take a look at how this is configured over in the VM here. All right, so let me get our browser back up and get the web. Oh, that's not what I want. There's our web console. And then we're going to take a look in the virtual machine that I've got running here in the background. This is basically our web server.
Wow, that's ugly.
That's
There's
interesting.
ugly here too, though, so at least.
Okay, at least it's across the
friendly.
board problem. Oh, there, I figured it
That's
out.
better.
All right. So we're going to take a look at our web.config. This is the one that we're actually running these tests against. So the first thing we're going to look at, as I mentioned, we have to actually add the section to our configuration file. So that's this guy right here. Zoom in on it. So you can see that. There's the name, and we're just referencing that DLL. Make sense? Scroll down to the actual configuration. So here's our caching configuration that we've got set up. We zoom in on this guy. So you can see here, we're actually just saying caching. We're not configuring the exact headers because we want the secure by default. But we do have a bunch of locations here that we're excluding. We're saying do not omit the cache control headers on these pages. So you'll notice the first one there is the content/vulnerable directory. That's the page that I demoed to you at the beginning of the talk. That's why we were able to do that, is because that's being excluded. And then in a real site, you typically would not want to cache or would allow caching of your images, your scripts, maybe your CSS classes, anything that's really just not going to change much over time. As long as it doesn't have sensitive data in it, we're okay with caching it, right? So there's a reason for both. We'll take a look at content security policy. This is a web forms application. So this is the exact same CSP that I showed you on the slide and the same CSP that's out on the Codeplex site. This is the CSP you need to use with web forms. So it allows unsafe inline, it allows unsafe eval, it has our inline CSS allowed. And these things weaken the security policy, but with web forms, that's what we have to do. The rest of them are pretty standard. We're not doing much with content type options and X-frame and XSS protection except just excluding that content vulnerable directory. Our third thing, if you remember, we have to actually register the module. So here's our registered module. It's right there in the web server modules section. We go ahead and drop that in there, and that's what tells the framework to execute this on every request. So very, very easy to set up. I'd say we probably, on all the assessments that we do, see all of these headers set on very, very few of them, probably less than 5% of the sites. So our hope is that this project will actually encourage people to just drop these in here and start using them without actually having to write any code.
So does it work?
It works. Let's see.
Well, show us, Eric.
Okay, you don't believe me?
No.
All right. So I have the same pages that we exploited earlier, except this time they're sitting in the safe directory, so the headers will be there, and we'll watch the headers get set as we visit them. Let me go back to the home page here. Try to get out of this frame. It's kind of... Okay. So let's go back home. Where'd that console go? There we go. All right. So let me go ahead and get the developer tool. That guy just keeps disappearing on me. There it is. Okay, so we're going to hit the caching page again. Remember last time we hit the back button and it showed up? So let's go ahead and go to the caching page, and let's take a different look at it this time. So there's our get. This time you can see, here's our headers. We've got the no cache headers set. We've got our content security policy set that works with web forms. We've got the expires header, we've got the pragma header, we've got strict transport security, we've got our XSS headers, our content type headers. All of those guys are in there because the module is just putting them right in the response before it comes back to the client. So if we come back here, remember we hit our default page again, and we hit the back button, and this time, if we go ahead and look at our network traffic, we can see the get this time. Remember last time it was empty because it pulled it from the cache? This time it saw, I don't have this page cached, I need to go ahead and make the request back out to the server to get it. So our caching is working, which is good. That's what we want. So let's take a look at our remote script include. This is the one that popped the evil alert box last time, right? Our beef hook was sitting in this page. Let's go ahead and hit it this time, and the first thing you'll notice is no alert box, right? So we don't have our evil alert box. That means something changed. We can come back and verify. Oh, where did that go? There we go. So see in here, our content security policy is set. That's good. And you can actually also look in the console, and you see the CSP exception right here. Has anyone monitored for these before if you're using CSP? You can just look right in the browser, and it's basically saying, hey, you violated the content security policy on the page. You requested a CDD exploit /script/evil.js file. That is not allowed in your whitelist of scripts in the content security policy. I'm denying it. So that's why that alert box didn't show up. That's how easy it is to stop attackers like us from injecting scripts into your site and running malicious code. Pretty easy, right? In our last example, we had our framing example. So we'll go ahead and click our clickjacking page here. And again, this time, remember last time our frame showed up, this time our frame is hidden. The browser has denied it because we're saying we cannot load that page into frames back on our side. So that prevents us from any clickjacking vulnerabilities that may show up. Any questions? That means we did a great job writing this.
That's
because
right.
No one has problems understanding it. All right, so let's bounce back into the slides here. There's only I just saw a calendar reminder. I have a golf league starting in 10 minutes.
Oh, you better get there.
Not going to make
It's
it.
only 2.5 hours away.
Yeah.
So some of the future things we want to do, we want to actually test support for .NET 3.5, .NET 4.0. Like again, theoretically it works, but we haven't actually tried it. We want to add a couple other headers in there, the access control allow origin and the origin headers. I want to add both of those in. And then the CSP 2.0 spec is out, so we'd like to put those headers into there so that if it ever gets approved and ratified and everybody's happy with it, then we can go ahead and start generating those too. And then if you want to go get the code, it's on shim.codeplex.net, module, tool, whatever. And then if you want to get this presentation or you want to go look at Eric's CSP webcast, it's on our website, cypressdefense.com. Just hit the blog and you can see all those on there.
We do have the Sans Accent booth right out of the door here. They're giving away t-shirts, also a bunch of cool posters and discounts for the upcoming event in network security. Go visit Kate at the booth if you haven't already. And
That's it. Any questions?
contact info's on there. Feel free to hit us. Yes?
Content security policy is not really that standard yet. So using it, for example, if I use this model and for setting up all these different errors, what would the coverage that I will have in terms of like market share for browsers, for example, like I said, okay, Internet Explorer doesn't really
Yep.
apply for some of the issues. It doesn't really respect the X-frame options. For content security policy, it's only sandbox.
Right.
And previous version of 7 and prior of that, they ignore everything.
Yep.
So what's the percentage? Have you identified how many?
So the question really, I think what you're asking is, because their support is different for all these headers, and because some of them are not supported by browsers, why would we use them? What is the coverage? And it's going to vary by your user base, right?
How do I use it? Because I think it's pretty valuable. But I think, like, what percentage of my users will be protected or
Right.
certain.
Well, these are certainly, and usually I have a slide in here that says this. We took it out. But really, these are defense in-depth countermeasures. Just because you put a content security policy in your site does not give you the right to do no output encoding of any of your dynamic data that you consider untrusted, right? You still have to encode your data. You can include frame-breaking code in your site to prevent clickjacking in older browsers. They're really intended to boost the security of your site, and as browsers roll out more and more support, then they grow in strength, right? But
Like you mentioned a second ago, just like all the HTML tags that the browsers don't understand, all of the headers that the browser doesn't understand, it just throws away. So
Yeah.
it really doesn't cost us anything to put them in there.
Yep.
For the browsers that support them, great. For the browsers that don't, we do know that they don't exist. We know that, you know, only IE and Chrome support half of the headers, but at the same time, for those IE and Chrome users, we've added some protection in there. But as to your question about how much protection does it really buy, it really depends on your user base. If you're talking about a collection of corporate users that are all mandated to use IE6, then you can definitely look at that. But if you're trying to take a website that serves, you know, anywhere on the internet and you're wide open, then only about a third of these headers are supported by the mainstream browsers, and so you're still going to get some protection. And again, like Eric said, if you're doing content encoding, if you're doing secure MIME types, if you're doing everything right, this just gives you one more layer to help come down. So.
Have you seen, for example, the event, eval, save, or I'm not sure what they're saying.
Unsafe inline? Yeah.
Have you seen that actually used?
Oh yeah, absolutely. Yep. I mean, it's very common. I showed you the report-only mode also. And in the SANS webcast that I mentioned, I actually take the perspective of, if say you have a new site, you have no content security policy, how do you start building one? There are some tools out there that will capture your website traffic, take a look at all of the different resources that you're pulling in, and it'll go out and parse all those logs, and it'll actually build you a content security policy. And then you can put that in your header and turn on report-only mode, and you want to do that in test, you know, your test staging environment for quite a while to make sure you haven't broken anything before you actually roll that out to your production site. You do have to be careful with it. That's a touchy one. So you want to make sure you do that with a lot of testing before you implement it. Have you guys had horror stories with it at all?
Yeah, as we speak.
That's why you're here. You're looking for a solution.
Yeah.
Right.
It's hard. So the one tool, actually I think it's on my browser right here. There's a Chrome plugin that's a CSP plugin, and you can actually just fiddle with it. So just any other questions as we're standing here, as I'm messing with this?
It's your tap dancing.
Is there a beer between now and the keynote?
When's the keynote? This is the first event I've actually, I knew what time I had to be here.
Time for beer.
4:30?
Oh yeah.
I'd say so.
There's beer
All right.
30.
Well, let's just do this. Okay, so you can see this guy here. Here's the icon. So this, I pulled this off of the OWASP site. So there's a link on there to this plugin. You can hit this guy, and you can go ahead and just start messing with all the different options. You can hit the apply button and save it, and then browse the site and watch those exceptions roll in. And it doesn't have a CSP header set, but this makes the browser think that it does. So you can test it that way. And then there's a more automated version of it. A fellow named Kenny-san from Etsy released it at DEF CON a couple years ago. It's called CSP Tools. And that you actually set your browser up to go through a proxy, and it captures all the traffic. And then you can run his parser, and that's what will build you a content security policy for you. So it'll catch the random images you're pulling off of Google Images and all that stuff. So it's pretty slick. But I demo that in the webcast if you want to go out and check it out. It's on the site.
Any other questions?
We're done early too.
I know, look at that. We've got plenty of time for beer now.
Absolutely. And we'll be around later. You'll find us in one of the happy hour events if you have questions you think